Hey everyone, I'm Divya, Product Manager in Azure Logic Apps. In this video, I want to talk about and show how you can use Logic Apps to build generative AI applications with the RAG pattern. We'll build a RAG based ingestion and retrieval workflow for an online music store. The online music store application that we are using in this demo was built with some legacy frameworks. We are not updating anything about the application. However, what we want to add is a way to use AI to generate sales insights based on the sales data. The sales data from this application is available in SQL, which will be the source of data for this demo. This entire application will be built using two key workflows. The first one will be an ingestion workflow where we'll read sales data from SQL. This is structured data in JSON format, which will then ingest in AI search vector store. Since this is text and LLMs do not understand text, we'll generate vector embeddings using Azure OpenAI connector. The second workflow will be a retrieval workflow, which would process the user prompt and generate a response using Azure OpenAI. So let's get started. Before we create the Logic App workflows for data ingestion and retrieval, let's take a look at some of the prerequisites. If you do not have already, you do need to create an instance of Azure OpenAI service and AI search service to create RAG based ingestion and retrieval workflows. I have already created one, so let's look at some of the details from these services that will lead in Logic Apps. This is my OpenAI instance, and from Logic Apps, we would need to create a connection to this instance. For that, we'll need information from keys and endpoint section. We'll need the endpoint URL to connect to and the keys to authenticate to this endpoint. Next, let's take a look at model deployments, which will also be needed in Logic Apps. In the deployments tab, you will see all the deployment models available to you. You will need the name of the embedding model and the chat model in your workflows. Now let's take a look at the AI search service instance. To establish connection to this instance of AI search from your workflow, you will need the URL and the API keys. Next, you will need an index. You can create a new index from this drop down and follow the wizard to provide all the information as needed. Since I have already created an index, let's look at the fields that are part of this index. The index defines the schema to store your content and embeddings. It always includes a unique identifier, which is the ID field here, the content of the document, vector embeddings, and the name of the document. When we ingest data from Logic Apps, we'll need to make sure that a unique ID is associated with each chunk document. We'll use this schema in Logic Apps when we do the data ingestion. Now let's take a look at the data that we are going to ingest in this demo. We'll read the data from sales order details table, and it has information about the sales of music albums. That includes title, artist name, music genre, and the revenue from the albums. You should be able to use your own business data and generate similar insights that I'm going to share with you in the demo today. All right, so let's take a look at the Logic app, which does the RAG ingestion and retrieval. Here I have a standard Logic app which has two workflows, one for the ingestion and the other for the retrieval. The ingestion workflow starts with a request trigger. The request trigger generates a REST endpoint for this workflow. This means that you can trigger this workflow like any other REST APIs. Instead of the request trigger, you could also use schedule based trigger to run this ingestion workflow at a specific schedule. Also, here we are doing data ingestion in bulk, but you could also use an event based trigger, for example, a trigger which would invoke this workflow every time a record is added or updated in SQL, and use this ingestion workflow to ingest individual records. The next step is SQL built-in operation to get all the rows from a table. The table name here is a parameter, and the value of that parameter is sales order details table, which I showed you earlier. Here is a compose action that prepares the parameters for the chunk and tokenize step. The parameter includes content in base 64 form, which is why we are converting the output of SQL to base 64. Next, we provide the document type, which is text, the splitting strategy, and the token length. Here we have a step to do chunking and tokenization of the document. Currently, we are using an Azure function to do this step, but we will soon have built-in actions in Logic Apps for document chunking and tokenization. The function app that we are using here is available in our samples, so you should be able to deploy and call it as well. The input to the function are the parameters that we prepared in the previous step. In the next two steps, we are preparing the input for the get embeddings action. To do that, we are converting the tokenized output from previous step to JSON. The JSON output from the previous step is then converted to an array. In this step, we are calling Azure OpenAI endpoint and get the vector embeddings for the chunk document. Here we are using the OpenAI embedding deployment model, which we are picking from the parameters. Next, we are going to take these vector impressions and ingest them into the AI search vector store. But before we do that, we need to take in the embeddings and map them to the index schema that we defined in AI search. So here we are getting the content from the previous step, providing the name of the document, getting the embeddings from the previous step, and giving a unique identifier for each chunked document. We ingest the embeddings created in the previous step into AI search vector store. To do that, we need index name and the document to index. The document to index comes in from as an output from the previous step, and the AI search index name is the one that we configured when we configured the AI search service. It is defined as a value in the parameter here. This is a very generic pattern that you can easily modify for other applications and types of data. Now let's run this workflow. The run is complete, so let's look at the run details. Here is the output from get rows from SQL, which is now going to be ingested into the vector store. The chunk and tokenize step created different documents for the SQL data. The data from the SQL was split into multiple chunks, and here in the output we can see those chunks in the text format. The OpenAI operation to get multiple embeddings generates the embeddings for the text chunks. Each of those chunks are then ingested into the AI search with a unique identifier for each chunk. This brings us to the end of the ingestion workflow, where we were able to read records from SQL, chunk and tokenize them, generate embeddings for those chunks, and ingest those embeddings into the vector store. Now we are ready to generate intelligent insights on this vectorized data using AI search and OpenAI. So let's look at how we can build retrieval workflow using Logic Apps for this data. Here is our retrieval workflow. The retrieval workflow also starts with a request trigger that creates a REST endpoint for this workflow so that it can be invoked from any chat application that you have. It takes in a JSON schema with a single string property for the prompt. The next couple of actions are compose actions, where we prepare the inputs that go into the get chat completion API from the Azure OpenAI connector. In the first compose action, we have the system message. In the next one, we have the sample responses. And in the third step, we have instructions to ground the responses from the AI. Next, we have the JavaScript code, which takes in the output from the previous steps and formats it in a way that it is ready for the get chat completions API. Here we are calling the get chat completions API from the OpenAI connector, which takes in the deployment identifier and the output from the previous steps. For the response received from the get chat completions API, we are calling the get embedding API to generate the vector embeddings for the prompt. In the next step, we use the Azure AI search connector and call the vector search API. To this API, we provide the index name, which is the name of the index that we created in the beginning, the embeddings, and the vector impressions for the prompt. Finally, we call the getChatCompletions API with the chat deployment identifier and the system message and user prompt. The response from the getChatCompletions API is returned back to the caller. This brings us to the end of the retrieval workflow. Now we are ready to run this workflow. You can call this retrieval workflow from any chat application that you have. For this demo, I'm going to use Postman and send prompts through that. Let's first find out which of the albums are performing well based on the data that we've ingested. The response, as expected, includes the top performing albums, their revenue, as well as the source of the document. Here I'm sending another prompt to ask which genres are not doing well. The response includes the genres that are not doing very well, the source of the data, as well as some of the albums that fall into that category. Based on this, I want to see if OpenAI can provide any recommendations on how we can improve these sales. And the response includes the genres that are doing well, the artists who are doing well, and also suggests different options to improve the sales based on the data, based on the trends and patterns. This brings us to the end of the demo. The sample is available in our GitHub repo. Please feel free to try this out and reach out to us if you have any questions, feedback, or feature requests. Thank you.